All right, so our plan, yeah, so we're on schedule, we're on good schedule. We're going to finish chapter 4 tomorrow and even start chapter 5, which is not on the test, but I want to get a jump on 5. It's our last material. So yeah, we're going to finish 4 tomorrow is the plan. Practice exam is on Thursday. Real exam is on Friday. And then we'll just have the 5th exam and the final, which are the end of next week, Thursday, Friday next week. You'll be done with this class in a week and 3 days. All right. So let's do about half this section. We'll do about half this section. 4.5. Slope-intercept form of a line. Find the slope and y-intercept of the line represented by the equation. Graph the equation by using the slope-intercept method. So y equals 3x plus 1. So we're supposed to take that equation and we're supposed to graph it. All right, so how do we do that? Y equals 3x plus 1. Find the slope-intercept. Do they want me to actually find it? Here, let me refresh it. Let me make sure. Okay, so what they want me to do, they want me to take this equation then, and from that equation, they want me to come up with a graph. Now, we're going to do it a new way now, and you'll like this way better. This will be easier. The way we did it before, we'll actually start assuming like the hard way. The way we did it before, yesterday and a little bit today, is remember we made the XY table? Well, yeah, we did a lot of it this morning, didn't we? It's been a long day. It's been 4 hours of math. The beginning of today, which seems like yesterday, back at from 7 a.m. to 8 a.m. this morning, we did the double zero tables. Remember those? And you can still do that. That'll still work, but you're going to like this better. This will be an easier way to go now. That way will still work. When you come to the exam on Friday, do it whatever way you want. If you just love the double zero tables, you can just do that on all of them. But I bet all of you, or 99% of you, will like the new way better. It's a little easier. It's quicker. So the other way, the new way that I'm going to show you now, is I'm going to take y equals 3x plus 1. And we're going to graph. So this is a new way to graph. Instead of making the table, instead of making the double zero table or any kind of table, what we can do is we just start with this number here. This number that's off to the right is your starting number. Positive 1 means up 1 in the middle. If that was a minus 1 here, then I would go down 1. What do I mean in the middle? I mean like right there. At positive, it's positive 1. So positive 1, up 1 on the middle line. If it was negative 1, I would go down to here. Negative 1 on the middle line. Does that make sense? It'd be down there if it was negative 1. But it's not. Good for starters. That's your first dot. We've already got one of our 2 dots. That quick. That number off to the right, that's your first dot. And it's always on the middle line. So if they had like 3x minus 7, I would go down 7. I would start right there. Right there. At down 7. On the middle line.
So the y-axis?
Yeah, on the y-axis. Exactly. Yeah. In fact, that's what this thing is called. I'll give you the official names. This number that's off to the right here is your y-intercept. Remember how we talked about x and y-intercepts? That is your y-intercept, that number off to the right. That is, when y is alone. So that's the one trick. You've got to have y alone in your equation. So you can't have x and y over there. You've got to have y alone, which we do. So when you have y alone, then the number off to the right is the y-intercept. So you can just start there, up 1 in the middle. That's my y-intercept. Is that good for starters? That's 1 dot. Now, how do I get my second dot? I need 2 dots to graph the thing. Roberto, you're here. Does everybody know Roberto? This is our assigned tutor. I don't know if you guys have gone for tutoring. Jose knows. So this is Roberto. It's good we see him every now and then. There's his hours up here. Remember, Roberto and I have been together for a year now, so he knows my ways of teaching, so he'll help you. He won't show you different ways, so if you need help, he's the man to go to. All right, so now, we got our 1 dot there at up 1. Now, where do we go from there to get our second dot? Does anybody know this already? Seen this before? Yeah, how do you know? Yeah, and then you put this over 1 like we always do. That's your slope. Right there in front of x, that's your road sign. telling you go this way, up 3 and over 1 to the second dot. But remember, a road sign always has to be from someplace, right? Like 23 miles to Yosemite. Well, we wouldn't want to plant that sign here because that's not true from here. That needs to be planted at a place that is 23 miles from Yosemite, right? So when this says rise, this is rise over run. It's rise 3, go up 3 and over 1 from where? From the first dot. So you got to start, that's why you have to start with the first dot. Once you have that anchored in, then from there, you just go up 1, 2, 3, over 1. There's your other dot. We got our 2 dots. Connect the dots. We got the line, we're done. No making tables. No plugging in zeros. Yeah, who's that?
So, would that work with if you have X only as well?
No, you got to get Y only. Only for Y. This is only when Y is alone. But they'll often give you Y alone. And when they don't, we'll just manipulate the equation and get Y alone. And we'll do the same thing. That's what our plan will be. So this is by far the easier way to graph it. You just, whatever number's out here to the right, when Y is low, whatever number's out here is your starting dot, up 1. Put your first dot down. And then from that dot, follow the road signs, rise over run. Go up 3 over 1. There's your second dot. Connect the 2 dots, you got your line. That easy. No making tables, no plugging in zeros, none of that. Is that good? Questions on that one? Shall we try another one? All right, try that one. Oh, they're going to ask me, now they're going to ask me questions all of a sudden. Okay, yeah, no problem. They're going to say, what's the slope, what's the intercept, and then graph. Okay, so first question, as you look at that, they're asking you, what is the slope? What is the slope on that one? It's the slope is that, right? It's the -8. It's not the -8x, it's not the x, it's just the number next to x. So that's the slope. Next question they're going to ask you, they're going to say, what is the y-intercept? So what is the y-intercept? Yeah, that's the -5. Whoops, to erase that. So they're going to ask, what's the slope? What is the y-intercept? And then they're going to say, graph it. So can we graph it? That's the important part. Let's go ahead and go to the graph now. Give that a try. Put your first dot. How do you find your first dot? The -5. Yeah, you start off to the right, huh? So in the y equals -8x minus 5, you start there. And that's the y-intercept, so it's always on the y-axis. Down 5. There it is at down 5. There's our first dot. It's always on the middle line. It's always on the y-axis. Positive is up, negative is down. It's down 5 on the middle. So we got that dot. Now, from there, how do we get to our second dot? Where's the road signs? Well, that's the slope. Put it over 1. Yeah, rise over run. Remember, slope is always vertical first. Rise over. Yeah, so down 8, huh? So from here, I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So from here, you go down 1, 2, 3, 4, 5, 6, 7, 8. Down 8 over 1. That's a very steep line going down. There we go. Mine looks a little bent, but there we go. That makes sense? So the first dot is at down 5, and then from there go down 8 further and over 1. Down 8 over 1.
And then you were saying even if you were to reverse it and make it -1, 8 over -1, it would still come out to the same line, right?
It actually would, yeah. If you made it 8 over -1, you would go up 8. 1, 2, 3, 4, 5, 6, 7, 8, back 1. See, and those 2 dots would make the exact same line. Anyway, don't worry about that. You'll be fine. You just do this, and it's all good. Let the bottom always be +1. You'll always go to the right one. That'll be the easiest way to handle it. Yeah. So here, let's go. Okay, try that one. Same kind of thing. They want you to graph it. All they want is the graph. So find your first dot. I have to charge up my pencil. Go unplug that for a minute. So it should be starting at down 4, right? Your first dot should be on the middle line, down 4. And then from there you go up 4 over 3. Is that right? I had to charge up my pen here. Let me see. It's probably good. It is. They say 30 seconds will last 30 minutes. That's Apple's claim. Seems to be true. So, all right. So, let's see. Yep, it seems to be working now. All right. So let me rewrite it right here. 4/3 x minus 4. So we start down 4 in the middle, the y-axis. So that'd be right there, and down 4. And now this is rise over run. So I go I go up 4. 1, 2, 3, 4. I'm up to the line, huh? Over 3. 1, 2, 3. There's our second dot. And then we just connect the 2 dots. Is that good? Does that make sense? Is this easier than making tables? XY table 0, 0. Well, you can do both ways. Either way you want on the test. Questions on that one? Okay, try that one. Some kind of thing they want us to graph. So figure out, be careful with that negative in front of the 4/3. Think carefully about what we've discussed about negatives on fractions. All right, so we start up 4 in the middle, huh? Start up 4 in the middle. So that's right there. Now where do we go from there? What do we do with this negative that's on the fraction?
We go down, right?
Well, does the negative go on both?
No.
Yes.
What is 2 negatives?
Positive.
So that's not right. Because that would be positive, wouldn't it? 2 negatives would be positive. So a negative in the front can't go on both, because that would then make it positive. So what does that mean? It's one or the other. Remember how we talked about that before? That when you have a negative in front of a fraction, you can put it on the top only, or you can put it on the bottom, but not both. Not both. Right? Because that'd be positive. So a negative, so one negative, it doesn't matter where it's at. Top, bottom, front, whatever, it's all the same thing. One negative in a fraction doesn't matter where it's at. Can't do 2 negatives. But 1 negative, great. Okay, so I can put it wherever I want. You know where the easiest place would be? just put it in the top. That's pretty much what I always do with fractions. Just put that negative in the top only, not both. Top only, that's easier to do with. So that would be a rise of -4 and a run of positive. So the negative's not on the bottom now, right? So the bottom is positive, isn't it? That's the easiest way to deal with it usually. So go down 4 then. 1, 2, 3, 4, because it's -4. And then right. That way I'm just always moving to the right. Does that make sense there? Just let the bottom always be positive, and that way you're always moving to the right. That's just easy to remember. That way if the thing's negative, you're going down and right. If it's positive, you're going up and right. But you're always going to the right. Positive up, negative down, and then always to the right. That's the easy way to deal with that. So there's our 2 points, and you know what you do from here. Just connect the dots. And we got it. Questions on that one? Is that good? All right, so negative on a fraction. What if I said to you, you could put the negative on the bottom, right? It's not easier, but it's true. You could put it on the bottom. If I put that on the bottom, then the top would be positive, right? Would that work?
Yeah.
I'm claiming it's true.
Still in line.
Yeah, because then from here you would go, remember this was our first dot here, right? You would go up 4, because now this is positive. Rise positive 4. And back 1, 2, 3. Look at that. It would be those 2 dots instead of the other 2. It's going to be the same line in the end, isn't it?
Yeah.
Math beautifully always works, as long as you follow the truth. But I don't want to confuse you with that, though. Don't do that. The easiest thing is just put that sign on the top. And that'll be the easiest way to go. Just always put the minus signs on the top. Caught what I was saying. This nice little method we've been using only works when y is alone. So we have to first get the y alone on this one. 6x plus 5y is 25. So first get y alone. Yeah, so and then we can do all the same stuff. You know, it'll be the same from there if we first get the y alone. So here's the wall. You guys are pros at this, as you proved on the exam I just gave back to you. With so many good scores, it was almost all A's and B's. And that was great. So solve for y. Get y alone. So y is saying, I want to be alone. Right? Can you do that? Go ahead and solve for y. We're used to solving for x. It's a little different here, huh? Solve for y. Get y alone. What's the first step to get y alone?
Subtract.
Last step is dividing, right?
Take 6x away from.
Get rid of the 6x first. Remember, we save the thing right next to the y for last. We'll divide the 5 off last. First, get rid of it's like peeling an onion, right? Start on the outside first and save the thing right near the middle for last. So first, get rid of the 6x. Subtract 6x from both sides. Gonzo. That makes sense. Always do the opposite, right? We always do the opposite to get things alone. Okay, what do we have now? This is 5y equals. Now, on this side, can I take 25 and subtract 6 and get whatever that is? No. They're unlike terms. If that was 25x minus 6x, I could totally subtract them, and I would get 19x or whatever. But no, that 25 is like, no, no, no. I don't interact with that 6x. Yeah, so you just put them side by side. Now, you don't have to put the x first, but it's usually done that way. It'll be easier for you probably. I mean, you could write 25 minus 6x. That's true also. But we usually put the x in the front. That's just how we're used to looking at it. Don't have to. Does that make sense, though, that you can't subtract them? Because they're unlike terms. Now, they don't both have x's, so we can't subtract them. So they just sit side by side. They can't interact. They're unlike. One more step. What do we do now to get y alone? Divide's always less, and when we divide, you have to do all three of them, not just two of them or something, all the way, why? Because the left side equals the right side. The whole left side equals the whole right side, so when you divide the whole left side by 5, you gotta divide the whole right side by 5, and they'll still be equal afterwards, right? They were equal before, treat them the same, they'll still be equal afterwards. So y equals minus 6/5 x plus, and what's 25 divided by 5? 5. There we go. We got y.
Is that wrong?
Took the 5y.
And trying to get rid of the 5 y instead of 6.
Yeah, well, we're trying, you want to get y alone,
The y.
which means get rid of the x,
Okay,
yeah.
so I was going with that, take the lower number.
Oh, yeah, no. Yeah, this one is specific for graphing.
Okay.
Graphing, it's very specifically y. We want to keep the y.
Okay,
Yeah.
yeah, that makes sense.
So it's just a different kind of thing we do just for graphing.
Okay.
Is that good on that? So now, can you graph it from there? Now that we have y alone, we can do our graphing technique, right? Let's go ahead and graph it. So where do we start? Start here, up 5 in the middle. Up at 5 in the middle. And then where do we go from there? Rise over run. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. Down 6. And then over 5, huh? 2, 3, 4, 5. And we'll play, connect the dots. And there we go. So the first one's at up 5, then down 6 over 5. Connect the dots. Questions on that one? Is that good? So everybody good with those steps to get y alone? No questions? We all good? We'll try another one of those. Those are a little more work.
Or to divide into a number that was by x.
Oh yeah, if this is divisible, then just go ahead and do it.
Okay.
Yeah.
And then it'd just be like
Over 1.
number over 1.
Yeah, just put it over 1, exactly. That's right, you've got. Five x plus 2y equals 10. Let's try that one. So try that one. So what do you got to do first? Get y alone. Get rid of that 5x. Yeah. First, get y alone. Okay, so first step to get y alone. Here's the wall. Y is saying I want to be alone, so get rid of this 5x from both sides. Okay, now can I subtract 10 minus 5x? No, they're unlike terms, huh? If it was 10x and 5x, I could subtract them, but it's a plain 10 and a 5x. No interaction. They're unlike terms. So you just put them side by side. We usually put the x term first. Minus 5x plus 10. Good. Last step to get x alone. Divide by 2. So y equals minus 5 halves x plus 5. 10 divided by 2 is 5, huh? Good. Now we're ready to graph. Now that we got y alone, we can graph. So where do we start? Yeah. Start up 5 in the middle. Right there. Up 5 in the middle, huh? On that one. Good there. That's a 5. Up 5 in the middle. Now, yeah, from there, everybody good with that? That's our first dot. Start. Up 5 in the middle. And then rise over run. So we go down 5. 1, 2, 3, 4, 5. Over 2. Like that. Down 5 over 2. And there's our second dot. No making tables. Connect the two. We got our graph. So we're graphing without making tables. We're just getting y alone, starting it up 5, and then down 5 over 2 for our second dot. Is that good? How many got that? How many got that graph basically right? Okay, good. It's a lot of you. Questions on that one? Good. All right. Let's try that one. Be valuable. Let's try that one. So I'll do it over here. So 3x minus 2y is 6. Yeah, try that one. Same kind of deal, right? What's first? Get that y alone, right? First, get y alone. There's the wall. Y is saying I want to be alone. So what do we do to get y alone? We subtract 3x from both sides. And we get minus 2y is minus 3x plus 6. Is that good to there? Can't subtract those, right? Because they're unlike terms again. So we just put them side by side. Now, what do we do to get y alone? Yeah, it's the negative 2, huh? Because remember, whenever we divide by the identical twin, huh? So we divide by negative 2, and it's all the way across, all three of them. Divide by negative 2 all the way across. And so what happens then, right here, two negatives, positive, and then on this one, only one negative, negative 3. Is everybody good with that? Everybody see what happened there, right? Because the two negatives here, two negatives. The negatives, even though the 3 and the 2 don't reduce, the two negatives cancel to be positive, huh? But over here, it's only one negative, so it comes out negative. Good with all that sign stuff. Can you graph it from there? So go ahead and graph it now.
Let me graph it using them both as negatives.
Yeah, that's actually true. Yeah, it's true, yeah. Yeah, in fact, maybe I'll show that. But anyway, let's do it first regular, and then I'll show that as well. So graph it from there. It's not very straight.
So at the end, the 6, you can divide 6 by -2.
Yeah.
Why do you not divide the -3?
Good question. Yeah. 2 doesn't go evenly into 3, it'd be a decimal.
1.5.
So we don't want, 1.5, so we don't want to mess with decimals.
Okay,
Yeah, we just simply don't want decimals.
okay. And I know we wanted it in fraction form.
Yeah, and we want this one as a fraction because we need rise and run, huh?
Right.
Yeah. Whereas this one, we don't want a fraction on here.
Because it's the x, too, right?
Yeah, whatever's next to x, we want to keep as a fraction. Yeah, well said, Melody, that's a good way to say it. Whatever's next to x, we want that to be a fraction because that's our slope. Exactly right. Whereas the number out here, we want it to be a whole number.
Okay.
You're right.
Because
So
I
we go
came
ahead
out
and
with a 1.5, I think, and then I thought, wait, where's the rise and
yes.
the run?
Yeah.
Okay.
Right, yeah, leave this one a fraction. Leave the one, yeah, Melody's question's right, everybody with her on that? Whatever's next to x, leave that as a fraction because we want a slope or rise and a run. Whereas the one off to the right, we just want one number. So just go ahead and divide those and get one number. Yeah, because that's our starting dot, right? This is where we start. So down 3 in the middle. Everybody good with that? That's our first dot. Down 3 in the middle. And then where do we go from there to get our second dot? Well, rise over run. Rise over run. So we're going to go up 3, 1, 2, 3, over 1, 2. Everybody good with that? Up 3 over 2. Connect the dots. There's our line. Which one is that? A, B, or C? B and A and B are close, huh? I can't tell.
Wait. Which one crosses -3? They both do.
I think it's A, if you look closer. Looks like A to me. You'd have to blow them up with a little magnifying glass. Yeah, because it made them real close. Yeah. Yeah, you know what the problem is? My graph isn't very because I did wider spacing on the X than I did on the Y, and so it really is A. It's steeper, right? Because it goes up more than it goes over. But mine, I didn't make it look very much like that. So you have to blow them up and count the dots on that one. Yeah. Yeah, good. Hey, Elizabeth mentioned that when she graphed hers, and she started at -3, like that, and then she left the negatives in there, would that actually work? Yeah, because it's technically true. 2 negatives is positive. Well, how would that work then if you left the 2 negatives in there? That'd be rise over run. So you'd go down 3, right? Down 3. And back 2. See the line's the same line? So that'll work. It's the same line. Just different second point leading to the same line. Yeah. So either way. It's easier just to get rid of the negative, so. Okay. So, yeah, I've answered the questions here. So they're giving us this equation. -3x plus y is 0. So go ahead, let's just do that. I think if you just do the regular thing, you'll be fine. So just try the regular thing on this one. Go ahead and just solve for y there. Which is what we always do, right? First step for graphing. First, get y alone. Solve for y, get y alone, right? So go ahead and just do the regular thing. Y, here's the wall. Y is saying I want to be alone, right? do just the regular thing. Get y alone there. So get y alone, see if that comes out for you. So what do we do to get y alone there?
Add 3x.
Good. Add 3x to both sides. Gonzo there, right? That puts y alone. This is 3x plus 0, huh? 3x plus 0. Good. Okay, now they're going to ask me, wait, what's the equation? Right here they asked, get rid of this. Right here they asked, what's the equation? Well, I just wrote, I didn't put the plus 0 because that's nothing. And then they said, what's the slope? This is the slope, the 3. Not 3x, but just the 3. Just the number next to x is the slope, right? Then they said, what's the y-intercept? That's the 0. That's the y-intercept, right? The number off to the right, which is nothing. It's just 0. And then finally, they're going to ask me to graph it. Can you graph that one real quick? So where do we start? When we go to graph the thing, where do we start? Yeah, we start right smack in the middle, huh? Does that make sense? Because it's 0. The y-intercept 0. And then from there, what do we do with the slope? What we always do, put it over 1, rise over run. So go up 3 over 1, up 1, 2, 3 over 1. Does that make sense? Rise over run, 3 over 1, like that. And then connect the 2 dots. So it'd be those 2. So this is a line that goes through the origin because his y-intercept is 0. Which line is it?
D.
Yeah, it looks like D, doesn't it? So that'll be easy to tell the multiple choice on that. Is that good? Does that make sense on that one? So they're just showing you about the 0 thing. They're just saying, hey, what does that mean when 0 is out there to the right? It means it just starts at the origin, huh? Everything else is the same. All right. We'll do this one more. So put this halfway through. We'll finish with our clicker quiz. And we'll be done. Let's graph that one. Today is June 6th. I just noticed when I was entering the quiz day. So, you know me, I'm a wannabe history teacher. So, World War II, June 6th.
D-Day?
Yeah, it's D-Day. 1944, June 6th. When we landed on the beaches in Normandy.
You like history? Have you ever watched Band of Brothers?
I think I've seen 1 or 2 of those a few years ago. That was a show out a long time ago, huh?
It's very, very good.
It was good. I did enjoy the 1 or 2 I saw, yeah.
I'll see you try to rant me on that.
Yeah. I like Band of Brothers because it shows them not knowing why World War II was happening. What
Okay.
everyone was doing during World War II.
Gotcha. More the soldier perspective.
Yes.
Right.
Boots on the ground, they're doing it, and then
Just have a job to do, and they, yeah.
I think they discover, was it Warsaw or Auschwitz in there?
Oh, did they?
One of the further on episodes.
Gotcha.
And that's when they find out
What's going on.
The encampments are for.
Gotcha. Right, right. All right, so what's the first step on this one? Solve for the y, right? Solve for the y. All right, so Y is saying I want to be alone. What's my first step?
Subtract the 8x.
Yeah. Gets rid of that one. So that's minus 8x plus 0. Good so far. And then how do we finish getting Y alone? Divide by the 5. And when we divide all the way across, right? That's a common mistake I see students make sometimes, is they'll only divide like these two. But dividing is all the way across. Now you gotta divide the whole left side, the whole right side. If they were equal before, you divide all of them, they'll still be equal. That's the idea, right? So the Y's cancel. I mean the 5's cancel. Y's alone. Minus 8/5 x plus. Now what is 0 over 5?
11.
It's 11. It's just 0, right? If you eat 0/5 of the pie, you had no pie, right? 0 on the top is just 0. And like Melody was saying, we want this to be one number off to the right. We don't want to leave it a fraction, huh? We just want one number. That's our starting spot, huh? We just want one dot. Whereas the other, in front of the x, we want two numbers, a fraction for rise and run, don't we? All right. So where do we start then on that graph? Start right at the origin. 0, 0. So all these ones that have a 0 out here are going to be starting at the origin, aren't they? Goes through the middle of the graph. Now, from there, we rise and we run. So we go down 8. So down 1, 2, 3, 4, 5, 6, 7, 8 over 5. 1, 2, 3, 4, 5. Down 8 over 5. Connect the dots. There's our graph. Graph goes through the middle, through the origin, because it started at 0. Down 8 over 5. Good on that. You guys are lean, mean graphing machines now. You can graph all these lines. Good. No questions? Is that all good? So we got halfway through. This won't be due. Just 4.3 and 4.4 like we originally planned will be due tomorrow, Wednesday. So 4.3 and 4.4. We didn't finish 4.5. We did half of it.